Hi there, and welcome to video tutorial number 4 or in the computing and numerical methods section of course CENV1025. This week I'm going to talk about classes. So in the lecture this week we looked at an example of classes. We built some different classes and we set up some inheritance between a standard base class called shape and then various child classes which were examples of shapes like rectangles and circles and squares. So what I'm going to do in this tutorial is I'm just going to show another example of building a class and talk a bit about the reasons why you might want to use a class to solve problems in this particular way. And I'm not going to talk about inheritance so much in this, or at all in fact in this tutorial. I'm just going to focus on using a class without thinking about inheritance too much. Obviously you can watch the lecture code on the lecture on Blackboard again and see the code that I wrote there, and also download the code on Blackboard if you want to look at a class, an example of classes using inheritance. So the problem I'm going to look at is a repeat of the problem we looked at in the last video tutorial and in the week 4 lecture, which was file input and output. So here we built a function which read a file, a data file. This was the data file containing heights and weights, samples of height and weight data measured from people in this kind of simple format, and we used our function to read the average height and average weight and return that as a tuple, although we didn't get around to implementing the weights part, you can see here. So what I'm going to do in this tutorial is I'm going to basically build a class which solves a similar problem but is a bit more flexible. So you can imagine that if you have some data in this format, you get some data in this format, there's a number of statistics that you might be able to pull out of this data, not just the mean of the heights and the mean of the weights. Like, you could also pull out the standard deviation, for example, or you could pull out the maximum height or the maximum weight or the minimum, and so on and so forth. So actually what you might want is a class which can read this type of data in this format and then have a number of functions associated with it to pull out statistics that might be of interest. And so if you wanted to do this in a function, you wanted to have a function that could have access to all the possible statistics that you might need, what you would need to do is calculate all those statistics and return them. However, as we're going to see when we do it in the class format, we just need to set up some basic first steps, and then we can have functions associated with the class which can, if we call those functions, pull out the required statistics, but if we don't, then they don't need to be run. Okay, so let's create a class called read height weight data, and we're not going to inherit, we don't need to inherit any functions from anywhere else, so we're just going to inherit from object. Now in our class constructor, we really just want the file name to call the file name of the data file. So we'll have file name. And we'll create a file object which is linked with this class. Okay, so we'll invoke the self keyword, and we'll call it the file, and we'll open the file that we've passed to the constructor. Okay. And then what I would like is, in the first instance, I just want to get the height and weight data out of the file and into my class as a list, as lists of floats. So I'm going to declare what I want here, just so I've got up front. I'm saying what I need, which is I need a list of heights, and I'm just going to populate that with an empty list to start with, and I need a list of weights. Okay, so the next thing I'm going to want to do is read the data out of the file. And what I'm going to do to make this kind of a bit more structured, I'm going to create a new function to do this, and I'm going to call it extract data. I'm going to pass itself so it can access everything, like for example the file, which we're going to need to get. And I'm just going to iterate over the file. So for the line in the file, I'll need the self keyword there, self, so it can find it. And then we know that the lines start with either the word height or the word weight, so I'm going to create a little control structure here. If heights in the line do something here, I'm just going to put pass in there now because I'm not going to actually fill that in yet. Elif weights in the line, and again pass. So I need to obviously get rid of those pass. Pass is a nice word you can use just to kind of fill in a space that you intend to populate perhaps later, or that if you don't want to do anything in there at all, you can use pass. So actually what I realise is that the thing I want to do in each of these situations, which is essentially read the numbers out of the line. So what I want to do here and here in the case is read these numbers into a list of floats. And I realise that that's the same operation pretty much. So what I want is, I don't want to write code in there to do it twice. What I want to do is create a new function which does that and call it in those two spaces where I've written pass. So if I create a new function called get data as floats, again give it the self keyword, and I'm going to pass it. In each case I'm going to give it the line that I want it to read, and I also need to tell it whether it's heights or weights. So I'm going to give it an identifier. And I'm just going to implement that here. So in this case, before I actually do anything in there, so here, if we were doing the heights case, I want to populate, I want to get the heights vector. This is what I want to get out of my function. And I'm going to call this function. So here, again, I'm going to self.get data as floats, and it needs the line that I'm looking at and an identifier, which in this case I'm going to use as the text, which is going to be this beginning bit of text on the line, particularly the bit that I want to get rid of. So I'm going to use heights colon. And I'll do the same thing. Self dot weights equals self dot floats the line. Okay, so what I'm going to need to do in this function is, first of all, get rid of the identifier, heights or weights, from the beginning of the line, and then read the rest of the numbers into a list of floats and return it. So let's just get that code in there now. So what do we need to do? First of all, we need to replace the identifier, heights or weights. And we are replacing it with nothing, because we just want to get rid of it. And then we're going to create a split line which is line.split. We're going to split it by the commas. We're going to create a float list. I'm going to now iterate over my split line list for num in split line, and at each one I'm going to float list dot append float num. Okay, so I'm going to convert my string. And my phone's ringing. I'm going to pause. Right, sorry about that. So yes, we've got a string. We've got a list of strings in split line. We're going through each string, which hopefully each one should be one of these numbers, and we're converting it to a float and adding it to our float list, which we're going to need to return. Going to save that. Okay, so I'm kind of conscious now that I've written quite a lot of code and I haven't actually run it or tested it yet. So let's do that just to step through. So I'm going to drop out of this class now, and I'm going to create a instance of the class. I'm going to create an object. Okay, call the constructor and give it the name of our data file, which is w4data.csv.
Lecture recording.
So now I've created an object called rhwd, which is a instance of the class read height weight data, and I've passed the name of the file to the constructor of the class. So now I've created an object, I can debug the code and step through it and see what's happening. So if I run, try again, there we go. So I can step into the constructor, create the file, create these two classes now. So that's all it's going to do at the moment, because I've only created the constructor. I haven't used any of these functions yet. What I'm actually going to do is add call extract data from the constructor, because I think we want to do this every time. So whenever we want to look at the data file and get some data out of it, what we want to do is extract the basic data, which is the raw heights and weights data, and we probably want to do that every single time. So the constructor is a good place to put that. Okay, so now let's see what happens. Let's try this again. We'll run, step in. Okay, so now we're going to be in our constructor. Now from the constructor we can step in to extract the data. And from in here we can step in excuse me, to get to this function which pulls out the data. And let's have a look at the variable explorer and see what we've got here. So we've got our float list Oh, that's not got nothing. Oh yes, we've got our split line, which has got all the data, the height data, and it's just getting written. Here it just gets written into the float list. You can see the numbers growing as we go through the for loop, and then we return that. Okay. So that should get all the data out. So let's just let's double check that works. Perhaps an easier way to do this than stepping through is actually just to view these two objects, heights and weights, because if everything's run correctly, then they should have been populated with the raw height and weight data. So we'll just print those out to see if we can see them. Okay, save, run. Okay, so it's printed out two lists of floats, the height data and the weight data, and they should be the same as the data in the file, which they are. So that's a good start. So that's the basis of the class. We've got a constructor that pulls the raw data out of the file and converts it from strings into floats so we can actually use them. And now what that's the wrong file. Now what we can do is we can add more functions to this class, which we can call at any time and can extract the statistics that we might be interested in from the data. So for example, get average height might be a function. We don't need to give it any inputs because it's going to use, except for self, because it's going to use the heights and weights that are already in the class. So this needs to return that, I think this will work actually. Self dot heights divided by length heights. So that should be the average. Notice I didn't actually bother creating a loop over the list heights because, in fact, Python has this handy built-in function sum, which will do that for me. If we want to get the average height, then we might want to also, we could also obviously have one for get average weight. I won't explicitly write that now because it will look exactly the same, except we'll call self.weights instead of self.heights. We might want to get the max weight which would be pretty simple. That would be max self dot weights. We might want to get other statistics too. Obviously, we can get the min as well as the max. We could get the average. We could get the standard deviation or the variance or any other statistic, the median or the mode or anything you might want to. We could get the sum, for example, sum of weights, the total weight in our data set. If you would want that, would obviously be return sum self dot weights. So, and I guess we should just check that these work by printing them. So, and you'll notice that all these functions we've created are now available to call from the instance of the class that we've created. And if we run, so there we go, it prints out the list of heights and weights, and then it prints out the average height, and it prints out the maximum weight. Good. So hopefully you can see that using this class structure is slightly more flexible than what we did in week 4, which was to just bang everything into a function. Using the class structure, in the constructor, we can do the tasks that we know we will always want to do when we want to get data out of this file, which is read the raw data out and convert it into a float format. But then in these other functions, which are members of the class, we can call functions that will calculate the statistics that we might need. And we won't necessarily always want to get the max weight or the sum over weights. We might only want the average weight, in which case this code never needs to get used. So it's quite a nice way of structuring your code so that everything, all the functions that are associated with reading this particular format of data are in the same place, and the jobs that you want to do every single time you want to extract something from this particular data, in other words reading them out the file and converting them into floats, are done immediately that the object, that the class is created, and then once the class is created we can call the various functions to get out the statistics that we want. And so that is another example of how to use the class structure in Python.